So we go right to our next workshop. And I would like to invite Maurizio Bernini, who is just right at the stage, the product manager, additive manufacturing and new technologies at CMS in Italy. And he has the topic making additive real. So how to implement 3D in the total process. CMS Group is also a very big company worldwide with 4,000 employees in Italy and abroad, and also spending this high amount of 7% for R&D. They have 3 main production centers, and all the leading Italian company, it's really the leading Italian company in the sector of machine tools and advanced composite materials. CMS is a partner of different sectors, different industry sectors, among those automotive, marine, aerospace, motorsport and railway industry. And Maurizio Bernini is giving us now a very impressive insight of what they are doing. Thank you very much. Please.
Thank you, Isa. Today should be the greatest day because also our product has a strong side concerning sustainability. Okay. I try to be quick in the CMS overview because some information was already said to you by Isa. This is our motto, the motto of our founder, that is, the machine is not important, but the customer needs. Our group, a group of 4,000 employees, 700 million of turnover, and 7% of turnover invested in R&D. We are in the machinery side, and we are manufacturing CNC machining center with different shapes, different sizes, and different function. The latest one is CMS Creator RS, large format additive manufacturing hybrid machine. Our sectors are the classical sector of composite, automotive, marine, aerospace, motorsport, railway. With a wide portfolio of special solutions. I am not going in detail in every solution because it takes quite a long time. The latest solution is the large format additive manufacturing combined with the milling, that is CMS Creator RS. One more step in composite development, but also other industries can take advantage of this. A good question. Why does a machine tool builder start to deal with additive manufacturing? That is something that is far from our tradition, something completely new, something needing an effort of research and development not small. This is why, to make money, maybe not in the immediate time, but to make it in the perspective. Because additive manufacturing is a young technology, a young industry, a young market, but with a huge growing pace. And here we can understand visually what I mean when I say that it is a young industry. In the timeline, there are some milestones related to composite industry. 1981, the first Formula One with a monocoque made of carbon fiber. Plastic industry. In my opinion, a good milestone is the Nobel Prize to Giulio Natta for the isotactic polypropylene. But the most important industry is the automotive industry. 1913, the start of the production of the Ford T. 3D printing industry is young. 1984, the first commercial patent. In 88, the second for SLA, for FDM, and our additive manufacturing, that is large format additive manufacturing, started 2014. And in this time, you can see the growth rate. In the early stages, until 2009, the growth rate was not bad, 9%. But in the period from 2009 and 2019, the growth rate rose to 28%. Why? Because additive manufacturing, starting from prototypes, goes to manufacturing, to industry. And especially large format additive manufacturing is focused on toolings. Toolings means 19% of share in the overall market. And is interesting for aerospace, automotive, and industrial machine. That is the 61% of the growth in this decade. But also marine can take advantage of this. And why? You will see where is the great competitiveness of the new technology. The competitiveness in terms of material, energy, and process time saving. Our solution have 5 milestones, 5 strong reasons why. This is what our marketing department said, have invented. That is unique solution. It is the only machine that integrates completely a machine tool for composite and a large format 3D printer. A raw material cost saving factor that is more than 5 when compared to traditional technologies. But also 5 times less material than competitors to print the same part. And in a context of FDM replacement, fewer part, less manufacturing time, and less cost than large-sized FDM. This is the machine. The machine is simply a CMS machining center, also coupled with an extruder to get the skew extrusion additive manufacturing and the standard milling. We have developed this project in cooperation with Fraunhofer. And in the picture you can see what is the huge perspective in terms of build volume that can be achieved by coupling additive manufacturing technology with a machine tool. In the right side you can see the range of strokes of our machines. And in the left side, the position, the same, that is the build volume of the current 3D printer on the market. By the way, the max build volume has to be updated because every day we try to do something more. And you will see an example that explains better than figures what I mean. One point is the quality of the extruded plastic. We have worked together to a prestigious Research and Development Institute because we would like to get the maximum obtainable quality of plastic. Just a figure that is not written there, but to understand what I mean. The young module of this material, the material that is printed in the picture, is that is PA6 with 40% of carbon fiber, is 13.6 gigapascal in the direction of the printing. In the interlayer direction, that is the most critical measurement, because it is giving a precise indication of the quality of the 3D printing, we have a degrade less than 1/2. That is 6.5 gigapascal, more than plastic. You know, ABS, 2-3 gigapascal of young module. That means vacuum integrity, the impossibility of having voids and making passing air or vacuum. We are using standard and high-performance thermoplastics, granulates, the same used in injection molding and in extrusion plants. You can see the example of polymer that we are about to use. We have used. Last week, we have exhibited a direct mold for autoclave made by the Daltram I350. But our German partners have tried on the same extruder, on the same project, also elastomer that are not interesting for us. Okay, integration between a machine tool and large format 3D printer means that there are no hoses, cables dropping from the floor. There is a machine with a complete automatic change from the milling and the 3D printing. It is the electrospindle, the engine that moves the screw of the extruder. And the electrospindle can pass from the mechanical tool to the extruder and vice versa with an automatic operation you can see there. The material feeding system is fully integrated in the machine. That is, hoses to bring the granulate to the extruder is completely inside of the robotic chain of the machine. But also, the material reloading and drying is out of the machine, and after having loaded and dried the first lot, all run automatically. Some example. A machining jig like that is, we have not so much example to be disclosed because we have several projects under mutual non-disclosure agreement, but this is a project that I can disclose. A jig like that usually takes 8 days at a supplier. Here we talk 3.5 hours to the 3D print, and not so much more for mill it. Because the 3D printing is just near net shape. Another example, this summer, CMS Creator was involved in the Resto Mode project. The Resto Mode is an old Maserati that was restored and modified. Resto Mode means restored and modified by changing some part of the body from steel to carbon fiber. And Lamination Master and the direct mold of this part has been 3D printed by Creator. The project was launched by Trussardi, and the execution of parts was by Bercella, a customer of us. You can see in the top picture. Another example, this part is a little bit more over the limits that we have seen before. This part has been 3D printed with 45 degrees 3D printing, and it is a Lamination Master of glass fiber sheet that we have defined to calibrate our universal holding feature table on a machine that has to be delivered to a CMS customer in the aerospace. The impressive data is the saved material. When compared to the subtractive technology, we have saved with this part 83 and 4% of material. You consider the solid part and the empty, vacuum, hollow part. We are also developing a large, high mass flow extruder, larger than the other one, up to 100 kilogram per hour, proper for marine application. But marine industry can take advantage also of the creator Ares, simply because there are a lot of parts to be manufactured with toolings with the size available on creator Ares. More than 5 is the saving factor of raw material cost, because, as I've seen before, solid versus hollow. In the top you can see epoxy ureol jig with the traditional manufacturing way, and below the same category of part 3D printed. 80% is clear, is the saving of material. And it is a green technology because the first way to reduce the plastic pollution is to use less plastic to manufacture the same part. And moreover, this plastic can be reused, but also less material than the one used by competitors. Our aim is less material and more printing speed. We have up to 5 times less material to do the same part when compared to the same part manufactured by competitors, without mentioning the competitors. The secret is the section of the 3D printing strand. Usually, everyone uses a rate of 1 to 4 to allow some small undercuts. We can execute an undercut of 45 degrees. But if you have a bigger strand section, you are quicker in rising the part, but you are wasting a lot of material. It can be used to manufacture toolings, but also other applications in the context of epoxy ureol or similar replacement. This is an example of FDM replacement. The customer, it is a customer, we started the commercialization in March, and we have 3 machines delivered and 2 machines about to be delivered. We have started the production of other machines for future customers. And the customer of these parts that has been shaded for confidentiality is manufacturing machining assembly jigs. And assembly jigs are made of a platform. The number 1 is can be replaced by a normal aluminum profile, is not significant. But the part number 2 and number 3 are the reference surfaces to lay up the part on this. Okay, the part number 2 and number 3 on an FDM 3D printer took 26 hours of 3D printing. On Creator, 2 hours of 3D printing and 3 hours of milling. A huge saving of material. And moreover, it is possible, thanks to the dimension, to reduce the number of subparts. Okay, we have seen that the 5 points are confirmed. Unique solution that integrates completely a machine tool and a large format 3D printing. More than 5 is the cost-saving factor compared to current manufacturing technologies, but also up to 5 times less material than competitors to print the same part, and fewer subparts in a context of extension of the capability of FDM 3D printing, in a context of FDM replacement. Our policy with new customer is contact us and challenge together CMS creator. We are proposing to customer first a confidentiality agreement, so we are more free to exchange information. And then I recommend customer give us some parts, a couple of parts, to be tested on Creator for the 3D printing. I recommend not the most complicated part of your life, neither the simplest one, but an intermediate part. We will study the feasibility because it is a new technology. It's not assured the feasibility of all. The way to cut the part, to have subparts or not. If possible, we do it monolithic. Times and cost of material on the computer. Then after the confirmation of the customer that there is the competitiveness of the new technology, we print the part, all this free of charge naturally. And to make the customer everything a way to use the machine, because it is a new technology. We know that after having used the machine, customers are more able than us to use the machine and maybe to be more effective on the machine than us. Some time ago, I have visited the customer of CMS working on a Formula One in the Midlands of UK. And I have discovered that the way they are treating the machine allow them to reach accuracies much more than the accuracies we are declaring on our documents, both official and also official that is contractual and also on brochures. So, I ask you if you have some question. I am glad to answer.
Thank you very much, Maurizio.
Thank you to you.
An applause for our CMS representative. Are there any questions in the room? Yes. Could you please bring the microphone close to the lady from BMW, our keynote speaker? Thank you.
Hi, Eva Hunikel from BMW. Are you able to start and stop in a process while the extrusion?
Very good question. We are able to start and stop the process, but for a short time. And we are studying the way to start and stop the process for the day after, I say. Because the point is, the quality of 3D printing is given by the thermal condition between the 3D printing layer and the already 3D printed layer and the new 3D printed layer. There is a window of heat, of temperature, with an upper limit that is not possible to 3D print because of the viscosity, too low viscosity because of the heat. And the lower limit where the connection between the two layers is too weak. The connection between two layers, we have 9 people working on the Creator Additive Lab. One of them is a student, a candidate PhD with a PhD program founded by CMS, and it is studied the phenomenon, and it is also inventing the formulas to transfer this knowledge also to all materials, because there is no literature on this, because these granulates are used for injection molding. Yeah. The parameter is the diffusivity, that is the channel between the already printed strand and the new strand. And this is ruling and having as a consequence the elasticity module interlayer, okay? We are working on it.
And the second question, what kind of CAD/CAM software are you using to get your files?
On our machine are open. I mean, CNC Center are open to every solution because when you are about to sell a machine, the customer is asking to use the software they are using currently on the factory, but also the numerical control. We are when a customer is saying, "Okay, I buy your machine, but please use this numerical control." Naturally, there is an extra cost, but we say, "Yes, thank you."
But the control.
For what concerning the software is something similar. We started with Siemens NX. Siemens NX because they developed a solution with an exclusivity for the directed energy deposition. That is the most closest technology to our machine. But there are several things that has to be developed. We are developing together with Siemens the software to have something more friendly to use, easy to use. But a large part of programs was programmed with freeware you can download from internet, because there are points of correspondence between our machine, our software, our machine, and FDM 3D printers. Yep. Okay? Yep. So we are open, but basically we are trying to have...
Any other questions? I have a last one otherwise for you, Maurizio. You mentioned aerospace and automotive as interesting markets. What about the marine market for large format additive?
I was thinking when David was speaking about marine.
Yeah, exactly.
I was thinking, it's really much interesting also for marine. Consider that.
I would say so.
A plug that is a Lamination Master for marine is something that has a cost, average cost of 50 to 75,000 euros.
Exactly, a lot of
if
material.
If you cut 80%, there is first cost saving, huge cost saving. Second, the material can be reused, not recycled, because there is no plastic, no polymer that can be seriously recycled. Every thermal transformation make the polymer losing a part of the chain, but reused, maybe in mixing with virgin material.
A promising market for the future.
Greta Day.
Yes, exactly. Thank you very much.
Is on global heating, but this is another way to be green.
Thank you very much, Maurizio Bernini. Another applause for our speaker for this really interesting introduction.
And thank you to your organizer. Okay.
Yeah, 2 days of exciting conferences and business meetings we experience now. It's just time to wrap up. Let me give you a short look back what we had, Lau. I would like to thank everybody, and I mean everybody, not everybody only here, but everybody who attended during the last 2 days, also our online attendance, on behalf of both organizers, JEC Group and AVK, that you supported the event, that you have been here, and that you have attended online. You know that JEC Forum DACH was a hybrid event, so we had the online attendance and coming personally to Frankfurt to experience this really exciting conference. And what did we have? We did have a firework of inspiring conferences, as I said, 9 workshops, 4 keynote sessions, and we had 6 topics like market development, environmental protection and sustainability, hydrogen, energy resource for automotive industry. We had thermoplastics in serious production. We had new applications for thermoplastic composites, and we had the composites for e-mobility. So 6 really gorgeous topics that we touched, and you will have the material available online as well after the conference. The political view on lightweight construction has been given by a very high delegate from the ministry in Berlin. And we learned that there is a considerable budget foreseen for next year for this sector. And now let me invite everybody for next year, because Eric Pierjean announced already yesterday that the second event of JEC Forum DACH will take place from the 29th to the 30th of November 2002 in Augsburg, in Munich. And the year after, of course, as well in Leipzig. But first, we would like to see you in Augsburg. And I think most of you will see again in Paris, of course, from the 8th to the 10th of March next year. So thank you very much, and stay with us for the future events. And have a safe trip back, and stay healthy. Thank you very much.